Hello and welcome to the course of Computer Network Part 2, and today we are going to discuss about broadcasting. In the last lecture we discussed about routing protocols which are used in the internet like routing information protocol RIP and open shortest path first OSPF, and the third one was BGP border gateway protocol. These are the three most dominating protocols work for internet, which are used for providing routing to the network. But these all the protocols are used for unicasting the packets. So today we are going to discuss how you can broadcast a packet or information into the whole network. Broadcasting is nothing but just providing the information to all the nodes present in that particular network. So how this thing can be possible, that we'll see. As we all know that there is a universal broadcast address which is used for broadcasting the information from one node to all the nodes present in that particular node. So that particular universal broadcast address is 255.255.255.255. If any packet comes in with this particular broadcast address as a destination address, that means that that particular router has to broadcast that particular packet to all the other nodes which are connected with that particular node. uh, it's very simple phenomenon. Three things are there: unicasting, broadcasting, and multicasting. So first of all, we should know what all they mean, and what are the differences between them. So first thing is unicasting. Unicasting means when a node in a network particularly transfers a particular packet or information to a particular destination with some IP address which is dedicated to a particular destination, and routing that particular information to a particular destination is called unicasting. Where broadcasting is like in a network, if let's suppose if you have 32 nodes present in a network, then if a node which is called a source wants to broadcast a particular information to that particular network, that means that particular node or source has to transfer that information to all the nodes present in that particular node. That is called broadcasting. And the last term is multicasting. Multicasting means in a particular network, instead of unicasting or broadcasting a particular information, you are providing that information to a number of nodes present in that particular network. That means not to all the nodes present in that network, but only a particular number of nodes which are present in that particular node, which uh, need that particular information. Those nodes which are associated with that particular information, or those who require that particular information, so that information should reach to only those nodes, not to the other nodes or the other nodes present in the network. So I hope we are clear with these three terms: unicasting, broadcasting, and multicasting. Unicasting means, again I'm briefing this thing once again, unicasting means one to one, broadcasting means one to all, and multicasting means one to many but not all. So how this happen, that we will discuss shortly, as we have already discussed unicasting, but today we are going to discuss broadcasting. So the first point which we see on this particular slide is deliver packets from source to all other nodes, which means that if this is a simple network which has got 4 nodes, and this particular router has to send a particular information to all the nodes present in this particular network. So what this particular router can do, this particular router will create a 3 duplicate packets. One is for R2, the other one is for R3, and the other one is for R4, which means router 1 will create a 3 duplicate packet, and this router will unicast those 3 packets to different destinations which are present in this particular network. Let's suppose router 1 is got some information. Router will create a packet and destined to R2. Router again will create the same packet, and that packet will be destined to R3, and again router 1 will create the same packet and unicast that particular packet to R4. So if a node present in a network unicast is its information to all the other nodes present uh, in this particular network, that is again is called broadcasting. But source duplication is required, which means that source has to produce n number of packets, which means source will unicast that particular information which it has to share with all the nodes. It will unicast that information to all the nodes, but this particular process is going to take a lot of bandwidth. This going to take a lot of time of R1. This particular node, this going to create a lot of uh, traffic in the network, because a single information or single packet which has to move to all the other nodes, but that particular packet has to move from this particular node to all the other nodes present in this particular network. So it can be a way to broadcast the information, but duplication is there. The second thing is source duplication is inefficient. This is the disadvantage of this particular thing which I told you just now. The second thing is source duplication. How does source determine recipient addresses? So the second thing which comes in our mind is that how this particular node R1 will get to know about all the IP addresses present in this particular network, because R1 has to have all the IP addresses of all the nodes present in this network to unicast information to all the other nodes present in this particular network. So it's going to be very difficult task for R1 to disseminate information using unicasting. So let's understand the other ways to broadcast the information. The second is flooding. But when you do flooding, if when node receives broadcast packet, sends copy to all neighbors, which means if this particular node receives a packet from R1 to broadcast that information, for broadcasting that information or for flooding that information, this particular router doesn't require all the IP addresses present in this particular network, because this time when you use flooding process, you do not this router doesn't require all the IP addresses, because this particular router will broadcast that information, and that broadcasting is done, or that flooding is done, with the help of universal broadcast address that is called 255.255.255.255. This is the universal broadcast address. If this particular router has to flood some information, so this particular router has to put this universal broadcast address in its destination address, and once that particular packet is received by R2, R2 will take out the destination address, and it will examine once R2 finds that that particular address is a universal broadcast address, then R2 will do nothing. It will just uh, sends that information to all the other nodes which are connected with R2. So R2 will transfer that information to R3 and R4. Now again R3 get that information. R3 will examine the destination address and finds that it's a universal broadcast address. Then R3 again will broadcast that information to R4, and that information R2 already received by, sorry, R4 already have that information by R2. So R4 will get the redundant information. Once R4 gets that information, R4 again examines the destination address and finds that address is a universal broadcast address, and R2 then again broadcast that information to the other node which is connected with this particular node. So R2 will again get that information. Now R2 gets that information from R4. Now R2 will again examine the destination broadcast address, and it will find that that is a universal broadcast address. Then R2 will send that information again to R1, which is actually the source of that information, and R2 passes that information to its other neighboring node, which is R3, which has that information from R2 as well. So it's going to create a broadcast storm. Flooding, simple flooding will going to create broadcast storm because of looping problem, because of cycles of that particular information. So again, this flooding is not required. A simple flooding is not required. Simple flooding has many disadvantages, as you saw, that it will create a broadcast storm. So the third way of broadcasting the information is controlled flooding. And how this controlled flooding is done, you can see node only broadcast packet if it hasn't broadcast same packet before. So how it's going to happen that thing? In controlled flooding, you have to provide ID numbers to the packets. Got the point? As you can see over here, node keeps track of packet IDs already broadcasted. So if R1 has to broadcast some information, and R1 broadcasts that information through R2. R2 will keep the ID of that particular information after broadcasting that information to R3 and R4. Once R2 is done with the task, if R2 receives that information again from R4, R1 will transfer to R2. R2 will keep that information, that this particular packet I have already broadcasted. It will keep that information. Then R2 transfer that information to R3, and R2 transfer that information to R4. Then R2 will transfer that information to R4. Again, it will get the, it must be having that ID of that broadcasted packet, so it will refuse to broadcast. If this R4 transfers that packet again to R2, R2 will stop that storm or cycle of broadcasting, which is forming a loop for flooding a particular packet. If all the routers present in a node keeps that information, that once a packet is broadcasted, you are not supposed to broadcast that packet to the other nodes again, uh, then it's fine. But again, it's not a foolproof technique, because redundancy is still there. R2 will receive that information or that packet again, and then R2 will find that this packet is already broadcasted. Then it will stop broadcasting that particular packet. So it's again a challenge for us, because that packet is coming to R2 again using the bandwidth of the network and creating traffic in the network. So again, it's it's a way to stop broadcast storm, but not a foolproof um, or a perfect broadcast technique. Or the second thing, uh, reverse path forwarding, only forward packet if it arrived on shortest path between node and source. Let's discuss what is reverse path forwarding. Reverse path forwarding is nothing but, let's suppose R4 is there, and R4 with the help of unicast routing algorithm distance vector, R4 knows the path to R1. Let's suppose that path is R1, R2, R4. So if any information coming to R1 is coming from R3, R4 will discard that information, because R4 knows that that information comes from, if any information comes from R1, it will come through R2. It is called reverse path forwarding. R4 is calculating the reverse path to R1 and finds that if this information is coming from R1, it has to come to R2. Otherwise, if it is coming from R3, that means these packets are redundant packets which might have received by me from R2. So this is called reverse path forwarding. It is also okay, but not a perfect way of broadcasting, because in reverse path forwarding as well, R4 will receive redundant information from R3. Then R4 uh, discard that information, or discard, or it doesn't broadcast that information to R2 again, because R4 knows with the help of reverse path forwarding that if a packet is coming from R1, so it has to come through R2, not from R3. So that is how it's done, but again, it's not a perfect way of broadcasting the information. So now, these are the three ways of broadcasting the information. First is deliver packets from source to all other nodes. What is the disadvantage in that particular technique? Source has to create duplicate packets and unicast that information to all the other nodes present in the network. So again, it's an inefficient way of broadcasting the information. And second important thing is how this particular node will get to know about all the IP addresses present in the network. The second is flooding. Flooding is done with the help of universal broadcast address, that is 255.255.255.255, but uncontrolled flooding can create broadcast storm. It will create cycles, it will form loops, and there will be a broadcast storm in the network, and that will let the network down. The third technique of broadcasting is controlled flooding, but controlled flooding is good, but not the perfect way of broadcasting the information, because redundant packets are received by the nodes. So there are two ways to do this controlled flooding. First one is keeping the track of packet IDs. If you receive a packet which you have already broadcasted, then you will stop broadcasting that information again, because you have the information that you have already broadcasted that information once, so you will not again broadcast that information. So somehow you will control the broadcast storm, but redundancy is still there. Second technique of controlled flooding is reverse path forwarding. We have just discussed that thing. Again, redundancy is there. So the perfect technique for broadcasting the information is spanning tree. So let's see how this spanning tree is created and how we can transfer the information through the spanning tree. So the first and foremost thing in spanning tree is there will be no redundant packets received by any nodes. So it means that it's a perfect way of broadcasting the information. So let's see how you can construct a spanning tree. Uh, First, construct a spanning tree. Nodes then forward make copies only along spanning tree. So the first thing which you see in this particular network is this network has got 7 routers. Broadcast is initiated at A, and you can see uh, A is broadcasting this information to C and B. Then C is broadcasting that information to F and E. Now they will not broadcast that information because uh, it's a spanning tree. A creates that information, sorry, B forwards that information to D and D forwards that information to D, because G is the part of spanning tree. There's no link between D and E. If D passes that information to E, then E may receive that information from C and D. May receive the redundant information. So this is the benefit of spanning tree. You can see these bold black lines are the are used for creating the spanning tree. And in this particular network, spanning tree is this. The same spanning tree is used by node D. If D has to forward that information, then D will forward that information to those links which are the part of that spanning tree. As you can see, D is connected with 3 routers directly, B, E and G, but D is forwarding that information to B and G only because these are the branches of spanning tree. But this thin black line is not the branch of spanning tree. So that's why D is not broadcasting that information, and due to that E is not receiving the redundant information. So once D broadcasts its information to B and G, then B has one more branch, spanning tree branch. It forwards that information to that branch and A receives that information. Now A again forwards that information to spanning tree branch E. Now again you can see that router C is got 3 directly connected routers F, E and P. But C is got only 2 spanning tree branches which are connecting F and E, not B. So it will forward that information to F and E only. It will not forward that information to B. If this information is forwarded to B, then B will get the redundant packet. So it is the beauty of spanning tree that nobody gets the redundant packet, and that is how you can utilize the bandwidth. You can control the traffic while broadcasting any information in a particular network. So now you are clear that how information is floated to all the nodes present in a network without uh, wasting the bandwidth, without getting redundant packets, without creating traffic. But how this particular spanning tree is created, that we'll see now. I hope we are clear with the spanning tree broadcast information. How a spanning tree. This is a spanning tree for this particular network, and we have seen that if A has to broadcast that information uh, is broadcasted in a very well way without redundancy. In the same way that the same spanning tree used for node D, and again it is this particular information provided by D is broadcasted in a very well way in this particular network without producing redundancy, traffic, bandwidth problem. So now the main task is, what we have to learn is how to create the spanning tree for broadcasting the information. So in this particular slide, we will learn how to broadcast the information. So first of all, in this particular network, we have to select a center node, which is also called a rendezvous router or center node. Each node sends unicast join message to that particular center node, and that unicast join message is sent with the help of distance vector routing algorithm. So first of all, in the whole network, we need to find a center node, and you can assume any node as a center node, which is which has reachability to all the other nodes present in that network. Try to find that node, but you can select any node as a center node. And once you are done with that, what all you need to do is, all let's take an example in this particular network that E is a center node. So all the nodes present in this particular network will try to unicast a tree join message to this particular node. So let's take an example. E is a center node, or E is a rendezvous router. Now F is sending that tree join message to E with the help of distance vector routing algorithm. And once that information is reached to E, this path or this branch will become the part of spanning tree. Now let's see. When B has to unicast its information to E, it will use distance vector routing algorithm, and B finds that this path is the shortest way to reach E. Then B will make these two branches as a branches of spanning tree. So you can see over here that we have now three branches of a spanning tree. Now let's suppose A has to unicast the information to E, then A finds this path is the best suited path to or the shortest path with the help of distance vector routing algorithm to reach this particular node, and A finds B, and B already has a tree join sorry already has a branch of spanning tree. Then A will stop over here because there is a path available to E from B. So when B is unicasting its information to E, B finds a spanning tree branch, then it will stop uh, unicast that information, and A will make this particular branch as a unicast branch. Sorry, your spanning tree branch. Now again, if C has to send a unicast message to E in this particular network in the shortest way with the help of distance vector routing algorithm, E finds this particular way, and it is this way means C is directly connected with E. So C will create this particular branch as a spanning tree, you can see over here. Now next, if G has to unicast any information to E with the help of distance vector routing algorithm, then G will transmit that information through D. Now D already has a spanning tree branch, so G will stop making spanning tree branches because G's unicast message finds a unicast branch. Then it will stop sending the unicast message to E. Now all the nodes present in this particular network have already unicasted their tree join message to E, and they have found the spanning tree branches, and our spanning tree is minimum spanning tree is created over here. So this is a spanning tree used for broadcasting the information in this particular network from any node present in this particular network. And there will be no loop formation, there will be no uh, broadcast storm, there will be no cycles, and there will be no redundancy. So it's spanning tree is a perfect way of uh, broadcasting the information without redundancy. So that is how you can broadcast that information. I hope broadcasting is clear, and if you have any problem, we'll discuss that thing in our interaction class. Thank you very much. Have a good day.